On today's episode, we are getting into the latest space news, including NASA's plan to get astronauts home safe from Mars, Rocket Lab attempts their first ocean recovery, and SpaceX has trouble with their new Starlink satellites. This is the space race. NASA is planning the first crewed missions to Mars as part of their overarching Moon to Mars roadmap for the Artemis program and beyond. While it's obviously going to be a challenge to get humans all the way to the red planet, into orbit, through the atmosphere, and land them safely on the dusty surface, there's still one major complication that we sometimes overlook. We have to get those people back home again, and that means launching a crewed spacecraft from the surface of an alien planet. On March 24th, Houston We Have a Podcast posted the final episode in their 11-part series on the Mars mission. 4 NASA engineers sat down with host Gary Jordan to detail how the agency was approaching the design of the Mars Ascent Vehicle, or MAV, and really the whole Moon to Mars program. Sitting around the digital table, we have Tara Polsgrove, lead systems engineer with the Human Landing System program, part of the Artemis program, but before that, she was in a leadership role on the Mars architecture team. Dr. Tom Percy, integrated performance lead for the Human Landing Systems program, part of Artemis, but before that, he led Ascent vehicle development for the Mars architecture team. Dr. Doug Trent, part of the Mars architecture team's entry, descent, landing, and ascent leadership. And finally, Michelle Rucker, who is currently the lead of NASA's Human Mars architecture team. The challenge of lifting off from another planet is something that we've never done before. Sure, we've launched from the moon, but that's basically interstellar travel on easy mode. Mars has an atmosphere, and thin as it is, it's still an issue to consider, and the gravity on Mars has around twice the gravitational pull of the moon. But there's more than that. It's been over 50 years since humans put a small crew on any planetary body, and there's much more to consider than just how to get back into orbit from the Martian surface. So, let's start with the aerospace challenges. First off, by necessity, any ascent vehicle is going to have to basically be a miniature rocket in its own right. The lunar LEM from the Apollo missions might have been incredibly small, but it was equipped to get a 2-person crew back into orbit and rendezvous with the command vehicle. The MAV is going to have to do the same thing, but fly higher, faster, and carry more people. The guests each take turns discussing that while the first crew to land on Mars will only be 2 astronauts, NASA plans to up that number to 4 on subsequent missions. Then there's the idea that the MAV has to operate like a habitat and laboratory for the crew while they are on the surface. This means that the MAV has to have amenities like a bathroom, but also that it needs to operate while upright in the Martian gravity as well as in zero-G environments. In terms of operation, the NASA engineers point out that the MAV has to be able to break through the atmosphere, get to a parking orbit way higher than the one for lunar operations, and still have enough left in the tank to meet up with the transfer vehicle that will take them back to Earth. The guests estimate that it will take about a day for the MAV crew to reach their transfer vehicle once they launch. That's too much time to spend in something as small as the old Apollo lander. But that brings up even more questions. For instance, what's the fuel situation going to be like? The engineers say that NASA is planning on sending the MAV ahead of the main mission to land automatically, which means that it either has to get all the way to Mars with enough fuel to reach orbit again, or the incoming crew have to refuel the MAV when they arrive. NASA is currently exploring some options there, like sending another automated mission with fuel just to be sort of a space gas truck for the mission, but the logistics of carting fuel across the Martian surface to refuel a vehicle that has been sitting in those infamous sandstorms for months or years is a little dicey. Unfortunately, the guests say that NASA isn't planning on making fuel on-site right now. The tech just isn't ready yet, but experiments like MOXIE will hopefully shed more light on that before we have to make too many of these clumsy runs to Mars. So, okay, NASA has feasible plans to get astronauts to Mars, get them to their MAV, and have the vehicle be able to get them home. But that's not even close to all the design challenges the MAV faces. One of the biggest concerns about sending people to Mars, or any other potentially living planet really, is the risk of contagion. We've got no idea what sort of viruses, bacteria, or other bugs could have evolved there. Most of our equipment can't sample for that sort of thing, and so the MAV has to be built to clean room standards. Similarly, they'll want to bring back samples, and so they also have to be accounted for. And finally, there's logistics. Most Mars missions we've sent have tried to land at really low altitude areas in order to give the vehicles more time to slow down and land safely. With the MAV, launching back to orbit will be the hardest part of the mission, so NASA is looking for a very high altitude spot. Then there's the problem that, just like on Earth, a vehicle trying to launch to orbit really wants to do so from the equator. This lets the planet's rotation help push the rocket, but that puts a significant limitation on where we get to explore, and the equator region just isn't that interesting. NASA's looking for water, and we know it's near the poles. So there's debate on what to do about that as well. Then there's the worry about the launch itself. Communication time between Mars and Earth has up to a 40-minute turnaround, so the crew would have to trust their automated systems to get them safely to orbit without help from the team on Earth. The lander that gets the MAV to the surface will become the new landing pad, one that can't be perfectly straight like those at Cape Kennedy, and when the MAV lights those engines, there will be damage, just like the SLS did to the mobile launcher during Artemis 1's liftoff. So what happens if that damages the MAV? All of these decisions have a cascading effect. Changes to the MAV, like needing a toilet or a 4-person crew, mean that the Mars lander it comes on will have to accommodate that extra mass, meaning the rocket carrying that whole assembly needs to be big enough. More weight, more fuel, you get the picture. The episode is only about an hour long, so if you have time, you should definitely check it out. The guests are very knowledgeable and have a lot to say. Michelle Rucker mentions that this podcast was a good opportunity for NASA engineers to get some time in the light, to communicate what their job is like, and I have to agree. We have a tendency to look at the future with bright eyes, but forget all the insane amount of details that need to be looked at in order to get us there. And to their credit, these NASA guests all seem to be very excited about their work. They seem certain that we are going to make this happen. And so should we, because we have some incredibly talented people working through these problems, and they definitely don't seem like the type of people to give up. Rocket Lab made their first successful recovery of the Electron booster using an updated and simplified recovery method that basically involves fishing the rocket out of the sea and bringing it back home. The successful mission marked their final launch contract for Black Sky, a company that provides geospatial surveillance for private and government agencies, and finished with a recovery mission for the Electron's first stage booster. The Electron rocket's first stage had originally been planned for reusability in a similar way to the SpaceX Falcon 9. The very light carbon fiber booster would fall back to Earth and be recovered, refurbished, and fitted with a new upper stage for another mission. However, Rocket Lab wasn't trying to land the booster like SpaceX. They were trying to catch it with a helicopter, and to their credit, they got very close. They even caught the booster once, but were forced to let it go during the attempt. So after those attempts, it's only natural that the company would begin looking into other options, and, as luck would have it, a cheaper solution showed up. During Rocket Lab's earnings call earlier this month, CEO Peter Beck suggested that the company could save some money by investing in waterproofing and just recovering the boosters from sea. Now, this would seem like the obvious alternative, but historically, rocket engines and other machinery related to orbital flight don't really take well to being drowned in salt water. Rocket Lab still had to recover their boosters either way. Even after a failed launch attempt, they still towed the rocket back to port, and to their surprise, the equipment turned out to be tougher than they had thought. Beck said in the earnings call that this turned out to be quite a happy turn of events. Electron survived an ocean recovery in remarkably good condition, and in a lot of cases, its components actually passed requalification for flight. Beck was referring to this test held back in September 2022, which put a recovered Rutherford engine on the testing stand and ran it through a static fire that went just about perfectly, passing all of the same acceptance tests Rocket Lab normally performs on their engines before use. So, for the March 24th launch, Rocket Lab added the ocean recovery as part of their official mission, as opposed to just a part of a regular cleanup. And at T plus 8 minutes and 20 seconds, the range reported that the Electron's chutes had deployed successfully. Going forwards, Rocket Lab is likely going to have to run some tests with their refurbished boosters to see if it will be fit to fly, but given that the Rutherford engines don't seem to have any problems with taking a swim, it's not likely that the booster's other components will suffer much either. The real win here is that Rocket Lab can begin to look forward to reusing some of their Electron boosters, which will be a major breakthrough for them. Reusability is the reason SpaceX's Falcon 9 has become such an affordable platform for launch contracts, and with Rocket Lab's Neutron being developed as we speak, it would be great for the company to have a little extra spending money. It looks like there might be some problems with SpaceX's new Starlink V2 mini satellites, as some of the batch launched on February 27th seem to be losing altitude. On March 22nd, a Starlink customer at Virtually Nathan on Twitter posted some Starlink orbital data charts and asked astronomer Jonathan McDowell if he knew what was going on. Not only did he get McDowell, but SpaceX CEO Elon Musk himself, who often pops into threads like these to clear things up. McDowell first suggested that SpaceX could be debugging a few of the new satellites, testing them for instabilities or hardware issues. This was a pretty good guess, as the V2 mini-sats are very new. This was the first batch in orbit, in fact, and they had several hardware and software changes from the V1.5 satellites used up until now. The biggest of those are the new Argon thrusters. The older sats used more expensive Krypton-powered thrusters to maneuver. Argon is cheaper, and SpaceX says the new Argon Hull thrusters give the V2 minis 2.4 times the thrust and 1.5 times the specific impulse, but that doesn't mean they don't need to be tested in orbit. And as Elon pointed out in response to McDowell's guess, there's lots of new tech in the new satellites, and some issues were expected. Elon went on to confirm that some sats will be deorbited, while others will be tested before raising altitude. Losing a couple of Starlink satellites is nothing new, especially when introducing a batch with new, untested technology, so there's no reason to doubt Elon's bit about SpaceX expecting some trouble with this batch. Given that even these miniature versions of the V2 Starlink hardware are bigger than the older V1.5 models, it was probably more ideal to send up just one load of 21 satellites and wait for the results instead of launching a couple dozen just to lose a bunch to impatience. But with that being said, losing a handful of satellites to ensure the rest of the fleet flies straight is a small price to pay. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do one long form essay and one news update every week. And if you'd like more, we've got 2 more on the screen for you right now.